For the last derivation of a compound angle is sine alpha minus beta. Now this one is a little bit complex, so there's a little bit more juggling involved. So I'm gonna try to explain it as best as I can. Okay, sorry about that. Sine alpha minus beta. Now this can be expressed in the co-function, which is going to be cos 90 minus alpha minus beta, right? And then from there we say cos 90 minus alpha minus beta has been cleared out into being cos 90 minus alpha plus beta, because now a negative by a negative, they give you a positive. So from there we can regroup, but then we are using the very first formula, so we need this part to be negative. So we will have something that looks now like this. Okay, let me just put this as an indicator that from there we have this. We will be grouping the 90 minus alpha in its form, but then we want to use the very first formula, so we'll have a negative sign here, but then breaking it like the second one, we would have negative, because a negative and a negative, they give you a positive. So now the juggling is both on alpha as well as on beta. So from there we are using the very first formula. I think it's always best to put it here, so that when we are substituting we know what happened to both of these. Cos alpha by cos beta plus sine alpha by sine beta. And so instead of the alpha, now we have this 90 minus alpha, and instead of beta we have our negative beta in that place. So then we will say, so this is a side note, let me indicate it. And so going back to this, now we have 90 minus alpha minus negative beta, which will then be equal to cos alpha cos 90 minus alpha by cos negative beta plus sine 90 minus alpha by sine negative beta. Okay, and let me just move back to create more space for that. Let's write the plus here and try to shrink my handwriting so that we can see the very end here. There we go. And then from there we have something that looks like this. We know that its co-function of the cos 90 minus alpha is going to be sine alpha, and this is the fourth quadrant with the negative angle, and the cosine function is positive there, so that stays like that. And here we have the sine function, and we are turning it into its co-function, which will be cos alpha, and here we have this negative beta with the sine function, so it will be negative sine beta. But then now this is one term, so it will be multiplying this by this positive, the negative by the positive, and ultimately turning this into being a negative or a subtraction. So we then say, therefore sine alpha minus beta is equal to sine alpha by cos beta minus cos alpha by sine beta. So just to recap real quick, how all of these are looking like. We have the first one, which is cos alpha minus beta. That looks like this: cos alpha by cos beta plus sine alpha. Okay, let me just move back. Sine alpha by sine beta. And then the second one is cos alpha plus beta, which is cos alpha by cos beta minus sine alpha by sine beta. And then the third one was sine alpha plus beta, which became sine alpha by cos beta minus plus I believe this is cos beta by sine, this is cos alpha by sine beta. Okay, yeah, I see it now, because there's a cos sine alpha and the sine beta, cos alpha and cos beta. And then from here we have sine alpha minus beta, which then is expressed in the manner sine alpha by cos beta minus cos alpha by sine beta. From what I have noted from this is that the cosine function, if it's negative here in the left hand side, then it will be positive in the right hand side, the sine. And if it's positive here in the left hand side, then it will be negative in the right hand side. But from the sine function, there's a direct correlation. If you have a plus here on the left hand side, there will be a plus on the right hand side, and if you have a minus on the left hand side, and there will be a minus on the right hand side. And so this will be it. Thank you.